Today we're talking about CCM6, reflections in the coordinate plane. Let's review a little bit about the coordinate plane and some vocabulary words that are important. So as you see here, I've got my x-axis going left and right and my y-axis going up and down. They're like two number lines put together. So here to the right of my x-axis, I have positive numbers, and to the left, I've got my negative numbers. And on my y-axis, going up, I've got positive numbers, and down, I have negative numbers. Where the x-axis and the y-axis meet, that's called the origin. I've got 4 quadrants, and then I've got a couple points that I've plotted here on my coordinate plane. What we're going to do today is we're going to take a point or a series of points, and we're going to reflect them. So, what is a reflection? A reflection is a transformation of a figure that flips over a line. So if you just think about a mirror that's reflecting your image, it's the opposite of your image reflected over, that space. So it's a reflection. So here, we're going to do 2 things. I've got a sketch of a coordinate plane, and I've got a point. If I were to reflect this point over the y-axis, here's my y-axis. I'm just going to reflect it roughly to show you what a reflection is over that y-axis. So I'm going to take this point, and if I reflected it, this point would be somewhere in this region. So I just reflected it over that line. I'm going to do the same thing here, except I'm going to reflect it over the x-axis. Again, this is a rough sketch of what we're getting ready to accomplish. I've got my point here in quadrant 2. I'm going to reflect it over this line, which we call the x-axis. When I do that, my image will fall somewhere in this region. Pretty simple, right? So, let's try a couple. It says reflect RSTV over the y-axis, and I've got 4 points. So the first thing I have to do is I need to plot RSTV on my coordinate plane. So that's why it's important to know a little bit about the coordinate plane before you get started. So I've got R is 1, 3, so I'm going to plot 1, 3. Once I plot it, I'm going to label it with an R. S is 5, 3, so I'm going to go 5, 3, S. T is 5, 1, so I'm going to go 5, but just up 1 unit. That was my T. And then V is in 1, 1. Okay, so I've got RS, TV, and now it looks like a rectangle. And I'm going to reflect that rectangle over the y-axis. So I'm going to take it from this location, and it's going to be somewhere over here. I'm going to flip it. So what I'm going to do is I'm going to count how many spaces R is away from the y-axis. R is 1 unit away from the y-axis. Therefore, it's going to be 1 unit away on this side. This is my new R. I'm putting a dash by it so that you know it's my new R, not my old R. We call this prime notation. So if I were to talk to you about this new point, I would not call it new R. I would call it R prime. That's my new image. I'm going to reflect S over. S is 5 units away from the y-axis on the right. So the new S, or S prime, will be 5 units away from the y-axis, but on the other side. So that's S prime. Notice it stayed horizontally where it was. It didn't move up or down, it just flipped over to this side. So it stays horizontally in the same location, it's just moving left or right. The new V will be just 1 unit away from the y-axis, but on the other side of the y-axis. And the new T will be 5 units away. Also, if you look, T is where, if I kept S going down and V going down, it makes the point of T. So if I continued S and V, I would get my T prime. So look here, I've got this rectangle. Now I have my new rectangle. Whoops. And one is just flipped. Okay? It's a reflection. Notice that my R and V are the closest to the y-axis on the right, and they're also just as close on the left. So that's very important. Now I need to record my new points. My new R was -1, +3. My new S was -5, +3. My new T was -5, +1. And my new V was -1, +1. If you take a look, you'll notice some similarities between the old points and the new points. Really simmer on that for a second, and we're going to come back and talk about why those similarities and differences could be important in the future. Okay, we've got CAB, and now we're going to reflect CAB over the x-axis. So this is a different, we're doing something slightly different. Now instead of dealing with the y-axis, let's change our mindset to think about the x-axis, okay? We've got to plot our points first. So I've got C is -5, +3. C, A is -2 but +1. And B is -2, +5. B. Okay, looks like a triangle. So I'm going to take this and I'm going to reflect it not over the y-axis, but now I'm going to flip it over the x-axis, which is right here. So again, I'm going to just count how many spaces our points are away from the x-axis. So the point A is only one space away from the x-axis, and it's on -2. So I'm just going to move one space instead of above. I'm now just going to move one space below. That's the reflection of A. It's the new A. I'm going to label it with prime notation. B. B is 5 units away from the x-axis in the positive direction. I'm now going to move it 5 units away, but down here in the negative direction. This is my new B, B prime. And C, I'm going to just bring it straight down. It is 3 units away from the x-axis in the positive direction. Now I'm just going to go below the x-axis and plot my new C, which is C prime. I've got a triangle, so it's maintained its shape and size. It just now reflected. Okay, it didn't move the entire thing down because my A is still the closest point to the x-axis. So it didn't move, it reflected. Okay, so let me write down my new points. My new C is -5, -3. It was -5, +3. My new A is -2, -1. It was -2, +1. My new B is -2, -5. It was -2, +5. So, what do we do if we don't have graph paper, but I'm asked to reflect points over the x or y axis? Well, here's what we're going to do. Make sure you copy this down. If you need to pause the video to write all this down, please do so. When reflecting a point over the x-axis, your x values will stay the same, but your y value will change signs. So if they were negative, they will now be positive. If they were positive, they'll now be negative. We noticed that just a second ago when we did our triangle CAB. When reflecting a point over the y-axis, the y values will stay the same, but the x values will change signs. So that's what happened in our first scenario. So let's do a couple examples. I'll do 1 point, then you can do the next. I'm going to reflect over the x-axis. I started with this point, W, at -1, +2. Well, my rule stays that my x value stays the same, so it's still going to be -1, but my y value changes its sign. So here my y value and my point is +2, so in the new reflected point, it will be a -2. Why don't you try reflecting t over the x-axis without a graph? Did you get -2, +5? Hope so. Now let's switch gears. Let's reflect these 2 points over the y-axis. So if A is 0.34, my rule says that the y values stay the same, but my x values change sign. So my x value is going to be the one to change. It was a +3, so now it's going to be a -3, but my y value stays the same. So my y value will stay a 4. Why don't you try this last one by yourself? So remember, your x value changes, but your y stays the same. All right, I hope you got these as your answer. Now you know about reflections.